Welcome to the AI Checkpoints. Today we're plunging into something really fascinating, a development that could fundamentally change how businesses actually deploy cutting-edge AI. We're talking about large language models, LLMs,
Mhm.
and specifically how we can make them incredibly smart, tailored for specific tasks, but without all the usual headaches.
Mhm.
Look, adapting these powerful LLMs, it's notoriously tough for specialized enterprise needs. On one hand, simple prompting, asking questions. It's easy, sure, but it can be pretty error prone, and
I
honestly.
agree.
It
Mhm.
doesn't get you that far with complex business stuff. Then you've got the traditional way. Fine tuning sounds good, right? But it needs massive amounts of human labeled data. And let's be real, for most actual business scenarios, that perfectly labeled data, it's just not there. Or it costs a fortune to create.
Exactly. That data problem, it's a huge bottleneck. Really holds back enterprises wanting to, you know, leverage AI effectively. It's this classic catch-22 situation. You need the special data to train the special AI, but getting the data is the thing stopping you.
Yeah.
But what if there was a different way? What if you could boost AI quality, cut costs, and use the data companies already have, the raw stuff,
Hmm.
without labeling?
Okay, now you're talking.
That's where today's topic comes in. Test Time Adaptive Optimization, or TAO. It's work coming out of the Databricks Mosaic research team.
TAO. Okay, let's unpack this because that sounds potentially huge. So the core issue has always been this data problem. Companies are swimming in raw info, inputs, queries, documents, whatever. But fine tuning. That traditionally means getting experts, humans, to sift through it all and label the outputs, the right answers, the perfect summaries.
Painstaking work.
Exactly. Incredibly expensive, incredibly slow. It's just been this massive roadblock for custom AI.
Yeah, and what's really fascinating here is how TAO tackles this. It completely flips the script. Instead of chasing that human-labeled output data, the core idea is using something called test time compute combined with reinforcement learning.
Test time compute. Does that mean it's computationally heavy when I use the model? Because that sounds expensive.
Ah, that's a great clarifying question. And no, that's the crucial bit. The test time compute in TAO happens during the tuning or training phase, not inference. So the model uses this compute power to explore lots of possible responses for a task. Then it learns by evaluating those responses. And it does all this based just on past input examples, unlabeled ones.
Okay, wait. So you shift the resource focus away from human labeling effort and onto like an adjustable compute budget during training.
That's the idea. It's a potential game changer for scalability.
And the final model, the one I deploy, it runs efficiently, low inference cost.
Exactly right. That's the key distinction. TAO uses compute to build a better model. Once built, it's fast and cheap to run. This is totally different from some other models you might have heard of O1 or R1, where that heavy compute happens every single time you ask for an output.
Right, which would rack up costs super fast in production.
Precisely. TAO avoids that. You invest compute upfront in training for a cheaper, faster model later.
Okay, this is where it gets really interesting. Let's get into the nuts and bolts. How does this system, the one detailed in the Databricks blog post, how does it actually manage to improve an LLM without that traditional labeled data?
Right, so the Databricks Mosaic Research Team's blog post, the one called TAO, using test time compute to train efficient LLMs without labeled data, lays out 4 key stages. Think of it like a cycle. First stage, response generation. It starts by collecting example input prompts for your task, things your users might actually type in.
Like customer support questions or summarize this report.
Exactly, stuff you might already be logging, maybe using something like Databricks AI Gateway. Then the system generates a whole bunch of candidate responses for each prompt. Not just one answer, but many possibilities. It might use different strategies like chain of thought or structured prompting. The point is diversity.
So the model is kind of brainstorming different ways to answer.
You could think of it that way, yeah. Exploring the solution space. These are just potential answers, remember, not prejudged correct ones.
Okay, makes sense. What's next after it generates all these options?
Stage 2, response scoring. This is where evaluation comes in. Each of those generated candidate responses gets systematically scored. How good is it? How well does it fit the task? And the scoring can use different methods. Maybe a reward model, another AI trained to judge quality.
Ah, an AI judging another AI.
Yep. Or you could use preference scoring, maybe having an LLM judge compare pairs of responses, or even task-specific checks, like custom rules you define. This stage basically quantifies the quality of each attempt, gives it a grade.
So it's like an automated quality check, but without a human needing to say, this is right, this is wrong. It's more nuanced.
Exactly. It's about relative quality based on defined criteria.
Okay, so you've got generated responses and they've been schooled. Then what?
Then comes the learning. Stage 3, reinforcement learning, RL training. This is where the magic happens, where the underlying LLM actually gets updated. The RL process uses those scores, the grades, as feedback. If a response scored high, the model is encouraged, reinforced, to produce similar outputs in the future. Low score. It learns to avoid that kind of response.
So it's learning from its own rated attempts.
Precisely. It refines its predictions adaptively, guiding itself towards the kinds of outputs that received high scores. It's learning the strategy, not just memorizing answers.
Okay, that's clever. Is it a one-shot deal or?
And that leads to the fourth and maybe the most powerful stage, continuous improvement. This really highlights TAO's self-improving potential. What does it need to keep learning?
Just more inputs.
Exactly. The only data it needs are example LLM inputs, which users create naturally just by interacting with the system. So as soon as you deploy an LLM tuned with TAO, it starts generating the training data for the next round of TAO. Your AI can literally get better the more people use it. It creates this data flywheel, as the Databricks team calls it.
A data flywheel. I like that. Inputs generate data, data improves model, better model gets used more, generates more inputs.
You got it. It's a continuous improvement loop happening in the background without more expensive human labeling. That's incredible for an enterprise setting.
It really is. The LLM is essentially improving itself, learning from its own performance. That's scalability defined.
And when you look at the results, connecting this to the bigger picture, they're genuinely surprising. The Databricks team found TAO achieves better model quality than traditional fine-tuning.
Better. Even compared to fine-tuning with thousands of human-labeled examples.
Even then, yes, that really stood out.
That's wow. And what about comparing to, say, proprietary models?
Well, even more impressively, they showed it can bring efficient open-source models like Llama 8B, Llama 70B, up to a quality level that's comparable to expensive proprietary ones. Models like GPT-4o or O3 Mini.
Without needing the labels that those big models were trained on.
Exactly. Zero labeling cost for that uplift. Yeah. That is a massive win for accessibility, for cost efficiency, democratizing high-quality AI.
It really levels the playing field.
Absolutely. The blog post goes into specifics on benchmarks like Finance Bench, that's synthetic questions about SEC docs.
Complex stuff.
Very. Or DB Enterprise Arena, which uses real human inputs, or Bird SQL for generating database queries. TAO gave Llama significant boosts, sometimes beating traditional fine-tuning. And it's not just for narrow tasks. They also showed TAO can improve an LLM more broadly. They ran it on Llama models using like 175,000 diverse prompts, coding, math, Q&A, chat, a bit of everything.
And the result?
Llama 3.370B saw a 2.4 percentage point improvement on a broad enterprise benchmark.
Okay, 2.4 points might not sound like a lot to everyone, but in LLM benchmarks, that can be significant, right? Especially moving towards something like GPT-4o.
It's a very significant jump, especially achieved with zero human labeling cost. It closes a noticeable gap.
So what does this really mean for businesses, for developers, it sounds like? Instead of throwing endless money and people at labeling data, you invest that, maybe more strategically, in compute power during the tuning phase.
That's the implication. You shift the investment.
And you get a higher quality model out of it, but one that still runs cheap when deployed.
That's the promise. Higher quality, low inference costs. It makes specialized, high-performing AI much more attainable.
It really democratizes things.
It does. And it also shows quality scales with that test time compute during tuning. The more compute you invest in that training, that exploration and refinement process, the better the final model gets.
But without making it slower or more expensive to use later?
Crucially, yes. Which, again, is so different from models needing constant heavy compute during inference. Those can be 5x, 10x more expensive to run, as the Databricks article notes. TAO turns a variable operating cost into a fixed training investment.
That makes a ton of sense economically. Okay, so for a business or a developer listening right now thinking, I want to try this, what are the practical steps? What do you need to make TAO work?
The Databricks blog points to two main requirements. First, you need enough example inputs for your task.
The raw questions, the prompts.
Exactly. Ideally, several thousand. You can collect these from your live AI applications or maybe even generate them synthetically if you're starting fresh.
Okay, so input data, what's the second thing?
Second, you need a pretty accurate scoring method. That's vital for the reinforcement learning part. It needs good feedback.
The automated grader we talked about?
Right. So for Databricks users, they mentioned using their custom reward model, DBRM, which is built for enterprise tasks. Or you can enhance it, add your own custom scoring rules that reflect your specific business logic or quality needs.
So the scorer needs to effectively capture what good means for your application.
Precisely. That's the secret sauce, really.
Yeah.
Plenty of raw inputs and a smart way to evaluate the outputs the model generates itself.
And then that leads back to the data flywheel idea as the best practice.
Absolutely. Create that flywheel. As soon as you deploy an AI app, start collecting those inputs, those user interactions. Those inputs then feed directly back into TAO for the next tuning round.
So the system just keeps getting better.
The more it's used, the more data you get, the better TAO can make the model. It's a self-perpetuating improvement cycle. Imagine a support bot getting smarter with every query, or a code assistant learning from every developer request.
It's a powerful concept.
It really is. And it raises this important question for the field, doesn't it? TAO shifts the main bottleneck away from human-labeled data, which is scarce and costly, towards compute, which is becoming more accessible. How might this shift, this new paradigm, accelerate the creation and spread of specialized AI across all sorts of industries, making really advanced AI more practical and affordable than ever before?
It feels like a genuinely new tool, a powerful lever in the AI toolkit. Definitely promises to bring high-quality, custom AI within reach for many more organizations. It's certainly an exciting time to be building in this space. Hit like and subscribe if you like the content. See you next time.